Welcome to another installment of FIRSTWA Television. Today we're talking about the nuts and the bolts. On this installment we're going to talk about fasteners. Fasteners include nuts, bolts, screws, things to attach things to your robot. It's really the sort of the glue that's going to hold your robot together. There are a whole lot of fasteners out there, and we have a lot of experience with them, so we're going to share with you the ones that make the most sense for you to use on your robot. So let's start off our little discussion about bolts by talking about the standard measurements for a bolt. If you go to buy these at the hardware store, or maybe you go to Tacoma Screw or something to purchase them, and you walk in and you say, I would like a bolt, they're going to ask you for the dimensions. They're standard dimensions, and once you know what they mean, it actually all makes a lot of sense. The first dimension that you're going to have to give them is the diameter. And the diameter is measured down here at the base. And this one is 0.625, which is 5/8 of an inch. So this is a 5/8 inch bolt. And now the next measurement they're going to ask you for is the length. So if I take this tape measure and I measure from the inside of the head out to the end of the bolt, I can see that it's 3 inches long. So far we have a 5/8 by 3 inch bolt, and a lot of times they'll want to know what the thread count is. Most bolts come in two sizes or two thread counts, the coarse and the fine size. You're normally going to use the coarse unless you have a reason not to. It's measured by threads per inch, so if I was to take this tape measure here and measure across 1 inch, I should get a fixed number of little thread ridges that I can count. It turns out that the standard thread count for a 5/8 inch bolt is 11. So the full qualification for this bolt then is I want a 5/8 inch by 11, 3 inches long. Again, this is probably a bolt that you wouldn't end up using, but what you will end up using a lot of is something about this size. This is a 1/4 inch bolt. I'm going to take the nut off and the washer off. So this is a 1/4 by 20, 2 inches long. And so that's how you specify a bolt size. And so these are sort of 3 basic parts that you'll end up using a lot of: a bolt, a washer, and a nut. So when joining these 2 little bits of metal together, I've got 2 of them here, I've drilled a hole through both, and I'm ready to stick a bolt through. So here's a bolt. I can put this through, and I can attach a nut to it. By the way, this is when you go to specify sizes for nuts, you would just walk in and you say, I need a 1/4 20 nut. Obviously, nuts don't really have length to them. This will definitely hold these together. There's a couple of issues, though, that I wanted to point out. Robots vibrate and shake a lot when they're headed across the floor, and you run into things, and vibration with nuts and bolts usually causes the nut to loosen up. And you'll find over time that this will just start to rattle and shake, and it'll start to rattle and shake some more, and eventually chances are this nut is just going to fall right off of the bolt. So that's a problem. To fix that, we normally use something called a lock washer. This split lock washer, as you can see, it has a little cut in it, and you can see that it acts like a little spring. So when I put this over this bolt and put the nut on, as this clamps down, I'm going to use a wrench to tighten it, you can see that the metal here, the metal of the spring is going to kind of jab itself into the nut a little bit. It's also going to jab itself into my aluminum just a little bit. And that will help hold this nut. So if the nut tries to wiggle a little bit, it creates just a little bit of extra friction that prevents that from happening. These are okay. A lot of teams use them, and I certainly wouldn't begrudge anybody using these. Another option is to use one of these. This is called a star washer. This is actually an external star washer. It has little ridges. I don't know if the camera can pick that up, but it works much in the same way as that split washer, but it has many more little ridges to cause friction. And again, you would put this behind a standard 1/4-20 nut, and now instead of holding it in one spot, you're holding it in about, oh, there must be about a good dozen spots around there. This is a KEP nut, KEP, and it is a 1/4-inch nut, and it has built into it one of these star washers. So it comes as a single, it comes as a single unit. Now the nice thing about using KEP nuts over these individual parts is that the KEP nut holds that washer on for you. So say for example, I needed to put a bolt on and a nut on, and it's in a horizontal position like this. Using a split washer, you have to hold that on and then somehow try and get your fingers up there to, you can see they're kind of a pain in the butt to get up there. And once you get it on, whoops, there we go. Once you get it fastened, it's not so bad. However, when you take this off, you're inevitably going to lose that split washer. Nice thing about the KEP nut is that the nut and the washer are all one piece, and you can usually get it started up there, and it will hold nicely. So my suggestion is to replace this 3/4-inch bolt with this 1/2-inch bolt. And you'll find that for most of the material you'll be using, which is usually nominally about 1/8 of an inch thick, 2 pieces make it 1/4 inch thick. The nut itself requires about 1/4 of an inch. So this 1/2-inch bolt should fit in there real nicely with this KEP nut. And then we'll tighten using the right tool. And if you look here, you can see that it's just flush with the top of this nut. So the key things I was trying to show you are that KEP nuts exist and are very useful, that you should use the correct size bolt, and I've also told you how to size things. So putting it all together, I am using a 1/4 by 20 by 1/2-inch long bolt with a 1/4-20 KEP nut to hold these 2 pieces of metal together. So one of the things you could probably do before the season starts is to go out and get yourself a nice nut and bolt kit put together. Turns out you don't really need every possible size. Another thing I forgot to tell you about bolts are they come in several different grades. There's the most common is grade 2, the next most common is grade 5, and there's another one called grade 8. What these grading numbers mean is it tells you how hard and strong these bolts are. A lot of us end up at Tacoma Screw. They have places all throughout the Seattle area. Make sure and tell them that you're working with a high school robotics team and get to know your nut and bolt supplier. They can actually be very helpful, and most guys at the front counter of a nuts and bolt supplier have a great deal of flexibility in the pricing. I would also recommend getting one of these cabinets, sorting things with the little bins and trays. It just is a great deal of help in keeping things organized. So if you need to take a whole bunch of nuts and bolts somewhere, you can just grab out one of these little trays. You'll also need an assortment of the other sizes, and so let me tell you about some of the other sizes that are available. Once you get below this is the 1/4 inch size. Unfortunately, when you start getting smaller than that, the measurement system changes on you, and it's okay. It's just you just have to know about it. Once you get below a 1/4 inch, they change to a numbered system, and the numbering is actually pretty easy. They have like number 12. This is a number 10. This is a number 8. This is a number 6. And they go all the way down to, they start going to 4 to 3 to 2 to 1. Diameter is number 6. Turns out to be just a little bit over 1/8 of an inch or so. 32 is the thread count, and then it comes in a length. So it's specified just like the other bolts are. I would probably try and find a good assortment of these. You end up using them to mount the Victors, or you end up using them to mount motor controllers and to screw into other various parts of your robot. I usually get Phillips head. You can also get something called a combo head, which is a Phillips and a slot. Okay, so this is a style of bolt called a cap screw. A cap screw is used oftentimes in machinery parts. You'll find them in the gear train of your robot. I think Andy Mark uses quite a few of these. They're typically a little stronger than the zinc-coated standard bolts. They also use a different style of head. It uses an Allen wrench head or a hex head or a hex key head. So you insert there, and you screw it like that. One of the common issues that we run into with the first kit of parts is some of the parts come in English or SAE units, and some of the parts come in metric units. Most of the rest of the world uses the metric system. So where this comes to bite you is when you have two bolts like these two little fellows. They look very similar in size, but they are actually different. For example, here we have a standard 1/4-20 bolt and a 6mm metric bolt. You can see they kind of look pretty much the same size, but if you hold them up real close, you can see that their thread counts are different. And you can also, you might be able to tell, but it turns out that the metric bolt is just slightly smaller than the 1/4-20 bolt. And where this really comes to bite you is when sometimes you'll try and put a 1/4-20 nut on the end of one of these bolts, and it'll start to go just fine, and then it'll get a little tight. And of course, your first inclination is to really reef on it to make it go. So you got to kind of keep an eye out for that. If something isn't really threading right and doesn't feel quite right, stop and check to see if you're actually using a wrong size bolt. One of my favorite ways of checking, for example, if two bolts are using the same size threading, or is here these are 2/4 inch bolts, and if I put them on top of each other, they actually lock because the threads will interlock. Whereas if I did that with this metric bolt, I'll find that it doesn't quite mesh, it doesn't quite fit. You can see the little gap there. I want to take just a sec and talk about the right way and the wrong way to work with nuts and bolts. It actually does matter. There is a right way of using the tools and of putting the nuts and the bolts together. Proper tools for tightening a bolt include a wrench like this. This is a combination wrench. It has an open-ended wrench, and this is called a box end wrench. A box end wrench will grip all of the flats, and the open-ended wrench will just basically handle two of them. If you really need to tighten something, using the box end is usually a better idea than using the open end. You can also use a socket. A socket, again, will grip all of the edges, and these can be very useful, especially if you have a ratcheting handle like this one. Make sure that you use a fairly small ratchet handle. You can apply enough force using a ratchet handle like this to actually break the bolt, so there's no need to go too big. This one is an extra one that I got at a hardware store once. It's only about 3 or 4 inches long. It's kind of nice. I can get in there and work with it and get things plenty tight. About the biggest you really want to go is one of these standard 3/8 inch ratchet handles. Again, you don't really need to reef on these things, so try not to over tighten them because you can end up breaking a bolt. Sometimes you can actually end up damaging a bolt without knowing it, and it will end up breaking during the competition, and that's a very sad thing because that'll cause your robot to fail. I highly recommend expending a few bolts with your students to let them see how much force it actually takes to break one of these 1/4 inch bolts. It's a good learning experience for everybody, and it'll just go to show you how easy it is to break them accidentally.